Hello everyone, welcome to the video lecture series on engineering mechanics. Today in this video we will discuss on the topic resultant of system of forces. In this video we are going to discuss resultant of system of forces, the graphical methods for finding the resultant of system of forces, and also the analytical methods or analytical formula for finding the resultant of system of forces. Let us see what is resultant of system of forces. The system of forces is nothing but the number of forces acting simultaneously on the body. To find the final or net effect of number of forces acting on the body, we need to find a single force which can replace the number of forces acting on the body without changing the effect. Now, the resultant is nothing but a single force which can replace the number of forces acting on the body. For example, a body is acted upon by two forces, 10 newtons and 5 newtons, as shown in figure. Both are in the same direction. What is the resultant of this system of forces? What is the resultant of the two forces? The resultant is 15 newtons acting in the horizontal direction. Similarly, if a body is acted upon by two forces at different angles, it is not in the same direction or in opposite direction. A body is acted upon by two forces at different angles. In this case, it is difficult to find the single force or net force acting on the body. Right? So now, let us see the definition of resultant force. A force which can replace a system of forces without changing the effect on the body. Right. Now, how to find the resultant of system of forces? To find the resultant of system of forces, we have two methods. One is graphical methods. In the graphical method, we have triangle law of forces, polygon law of forces, and also parallelogram law of forces. In the analytical method, we have a formula derived by using parallelogram law of forces and the method of resolution. These are the methods available for finding the resultant of system of forces. Let us see the triangle law of forces first. The triangle law of forces states that when two forces acting on the body are represented by the two adjacent sides of the triangle, then the closing side of the triangle in opposite order represents the resultant of two forces. See this example, a body is subjected to two forces, 10 newtons is acting horizontal and 15 newtons is acting in the vertically downward direction. Now, the graphical representation of these forces are like this. 10 Newton force represented by a line 10 mm and the 15 Newton force will be represented by 15 mm. We can take any suitable scale to represent the force as a line. Now, these forces are taken as the two adjacent sides of the triangle in order. See, where the 10 Newton force is stopped, from that place 15 Newton force is started. This is in order. AB, BC are the two adjacent sides of the triangle. Now, the closing side is CA. Now, the closing side is CA. If you go in order from A to B, B to C and C to A is the order. But the triangle says the closing side of the triangle in opposite order gives a resultant. The closing side of the triangle in opposite order gives us the resultant. That means by using triangle law, if we wanted to find the resultant of these two forces, we need to draw two adjacent sides of the triangle in order and measure the third side measure the third side by using a steel rule, and that length will represent the magnitude of the resultant, and also the angle made by the resultant with any one of the force will be the direction of the resultant. By using triangle law of forces, we can find the resultant of two forces only. If more than two forces are acting on the body, we need to go for polygon law of forces. The polygon law of forces states that when three or more forces acting on the body are represented by the sides of the polygon in order, then the closing side of the polygon taken in opposite order will represent the resultant of the system of forces. Let us see the example. Three forces are acting on the body. Now draw the force polygon by considering suitable scale. Now 10 Newton force is represented by 10 mm line in the same direction, and then other forces also will be represented by the lines. Now these forces are drawn in order. The first force, where the first force is stopped, the second force will exactly start from that location. Right? Now these forces are taken in order and they are representing the adjacent sides of the polygon. Now what is the resultant here? The closing side of the polygon in the opposite order gives us the resultant. That means the line AD represents the resultant. To find the magnitude of the resultant here, measure the length of the AD line and convert into again newtons by using the same scale which we have used, and similarly find the angle of AD with respect to any one of the force. This is how we can find the resultant of system of forces by using polygon law. Now let us move to the next graphical method, that is parallelogram law of forces. The parallelogram law of forces states that when two forces acting on the body are represented by the two adjacent sides of the parallelogram, then the diagonal passing through the intersection of the two sides will represent the resultant of the two forces. Once again, this parallelogram law is applicable only for two forces, but this is the basis for finding the analytical formula, which we will see in the later slides. See the parallelogram law. Now a body is acted upon by two forces, 15 newtons and 10 newtons. As per this law, if the two forces are taken as the two adjacent sides of the parallelogram, let us see how to represent these two forces as the two adjacent sides of the parallelogram. See, take 15 newtons force exactly in the same direction, horizontal, and 10 newtons like this. 10 Newton force is represented by 10 mm like this. Now these two are forming two adjacent sides of the parallelogram. Let us see how to form. Draw a line parallel to AB, draw a line parallel to CD, draw a line parallel and equal to AB, and draw another line parallel and equal to AC, so that we can construct the parallelogram. Now the resultant is AD, the diagonal passing through the intersection of the two forces, that is nothing but AD is the resultant. To find the resultant magnitude, simply measure the line length, AD line length, that will be our magnitude, and find the angle with respect to any one of the forces, that will be the direction of the resultant for these two forces. Now let us see the analytical formula for resultant. The analytical formula for finding the resultant of forces derived by using the parallelogram law of forces. When two forces P and Q are acting at an angle of theta between them, as shown in figure, now construct a parallelogram by using parallelogram law of forces. So, AB line is representing P and AC line is representing Q. Construct the ABCD parallelogram. Now, the AD, which is the diagonal, will represent the resultant. To find the length of AD, or to find the formula for finding the length of AD, simply extend the line AB horizontally and drop a vertical line from D to intersect the horizontal line at E. Right? Now, in the right angle triangle AED, see the right angle triangle formed here, AED. In the right angle triangle AED, AD is the hypotenuse. By using Pythagoras theorem, we can calculate the length of AD. The resultant AD is the hypotenuse in the right angle triangle AED. As per the Pythagoras theorem, hypotenuse square is equal to side square plus side square. Look at the triangle. AD square is equal to AE square plus DE square. AD square is the hypotenuse, AE square is the side of the right angle triangle, DE square is another side of the right angle triangle. Now, AD square is nothing but R square, resultant square, and AE is written as P plus BE. AE is written as P plus BE. P plus BE whole square plus DE square. This AB plus BE whole square is in the form of A plus B whole square. Now, expand this. R square is equal to P plus Q cos theta whole square plus Q sin theta whole square. AB is P and BE is Q cos theta. This is Q cos theta and this is Q sin theta. To know this, just consider the right angle triangle BED. See this triangle BED. The BED triangle, right angle triangle, here we can see the adjacent side is BE and the opposite side is DE. Right? So from this right angle triangle, we can find BE and DE. Substitute these two values in the equation. BE is Q cos theta and DE is Q sin theta. Right? Now expand this. Right? R square is equal to P plus Q cos theta whole square is expanded like this. P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Again simplify this equation. P square, and I am taking Q square common, sin square theta plus cos square theta plus 2PQ cos theta. Sin square theta plus cos square theta is equal to 1. Now the equation becomes R square is equal to P square plus Q square plus 2PQ cos theta. Resultant R. Now find the resultant. R is equal to under root P square plus Q square plus 2PQ cos theta. Resultant R is given by the expression under root P square plus Q square plus 2PQ cos theta. This is the analytical expression for finding the resultant of any two forces acting at an angle of theta. Now find the direction. The magnitude of the resultant R is given by the expression R equal to P square plus Q square plus 2PQ cos theta. Now find the resultant. The resultant is making an angle the resultant is making an angle alpha with respect to force P. The resultant R is making an angle of alpha with respect to any one of the force. In this example, it is making an angle alpha with P. Now let us find the angle alpha by using the right angle triangle AED. Tan alpha is equal to opposite side by adjacent side, DE by AE. Tan alpha is equal to DE Q sin theta and AE is P plus Q cos theta. Alpha is equal to tan inverse Q sin theta by P plus Q cos theta. This is the expression for finding the direction of a resultant. Let us verify the equation. We know that when two forces are acting in the same direction, the sum of two forces is the resultant. Or to find the resultant of two forces acting in the same direction, simply add them. Similarly, when two forces acting in the opposite direction, the resultant is difference between the two forces. Let us verify the equation. Case 1. When two forces acting in the same direction, let us P and Q are acting in the same direction, angle between the two forces when they are acting in the same direction is 0, theta equal to 0. Write the equation. The resultant is given by P square plus Q square plus 2PQ cos theta. Here cos theta cos 90 is equal to 1. The expression leads to under root P square plus Q square plus 2PQ. It is in the form of A square plus B square plus 2AB, which is nothing but A plus B whole square. So R is equal to P plus Q whole square, which is nothing but P plus Q. See the second case. When two forces acting in the opposite direction, the angle between the two forces when they are acting in opposite direction is 180 degrees. Write the equation. R is equal to under root P square plus Q square plus 2PQ cos 180. Here theta is 180. Cos 180 is minus 1. Now the expression leads to under root P square plus Q square minus 2PQ, which is in the form of P minus Q whole square. R is equal to P minus Q whole square under root, which is given by P minus Q. Here square root and square gets cancelled. Resultant is given by P minus Q, the difference. Let us see another case, that is when the two forces acting perpendicular to one another. That means P and Q are at right angles to one another. Theta is equal to 90 degrees. Now write the equation once again. R is equal to P square plus Q square plus 2PQ cos 90. Cos 90 is equal to 0. So that expression becomes R is equal to P square plus Q square. When two forces acting at right angles to one another, the resultant is given by under root P square plus Q square. Now find the direction. When two forces acting at right angles, find the direction of the resultant. In first two cases, direction is not required. Why? Because when two forces acting in the same direction, the resultant will be definitely in the same direction, because both are acting in same direction. In the case 2, when two forces acting in opposite direction, the resultant will be in the direction of maximum force. We are finding the difference of two forces, and the direction is the direction of maximum force. But here in this case, when at right angles, we need to find the direction of the resultant also. The expression for finding the direction of the resultant or angle made by the resultant with one of the forces is alpha equal to tan inverse Q sin theta by P plus Q cos theta. In this case, theta is equal to 90 degrees. Theta equal to 90 degrees. Substitute angle 90 degrees in this equation. Alpha equal to tan inverse sin 90 by P plus Q cos 90. We know that sin 90 is equal to 1, cos 90 equal to 0. Therefore, the expression for alpha is given by tan inverse Q by P. Tan inverse, the ratio of vertical force to horizontal force. This is how we can find the resultant of any two forces acting at any angle theta by using the analytical method. In this video lecture, We have seen the resultant of system of forces, the graphical methods for finding the resultant, and the derivation of analytical formula for finding the resultant. Thank you.